Okay, so this is Chapter 1, Lesson 1 for Math 8. And we are going to kind of jump right on in here to rational numbers. So they first have us doing some fill-in-the-blank notes at the top of the page here. So we start reading. It says there's two blanks, so blank blank, are numbers that can be written as the ratio of two integers in which the denominator is not 0. All integers, fractions, mixed numbers, and percents are blank blank again. So if we kind of think about this logically, we have this big rational numbers here, and then they're giving us a definition. So didn't mean to go to the next page here, silly computer here. So we can kind of rationalize that we're going to fill this in with rational numbers. And this is in fact correct. So rational numbers are numbers that can be written as a ratio of two integers in which the denominator is not 0. So we really never want the denominator to be 0. And there is a really fun example of that I don't think it's on iPhones anymore. When you used to ask iPhones, why can't you divide by 0? When you'd ask Siri, she would give you this really funny story about Cookie Monster and his cookies, and he has 0 friends, but a lot of cookies, and now he's sad. She would go through and do this whole explanation. But really, the idea is, if you have a pizza, I like doing a pizza because, we can very easily divide that up into pieces. So if I have a pizza with 5 pieces on it, and there's a 0 on the bottom of my fraction here, well, I have 5 pieces, but this tells me how many pieces were total in the pizza to begin with. So I began with 0 pieces. There's nothing there. But now I have 5 of those 0. Doesn't make any sense. How did I get 5? There was 0 to begin with. So that's why we don't want to have 0 at the bottom. Just kind of a quick explanation. All integers, fractions, mixed numbers, and percents are rational numbers. Okay, so the next piece here, we have blank blank is the decimal form of a rational number. So we just want to make sure, and they're not giving us any hints on this one, so we would definitely need to know this one or have our textbooks open. If you don't have a textbook, you can get one from your teacher. If you're a part of a Google Classroom, it may also be on the Google Classroom as a digital format, but in this case, what they're talking about is a repeating decimal. Am I spelling that wrong? Whoops, I did. I spelled that way wrong. Repeating decimal. All right, so repeating decimal is the decimal form of a rational number. A repeating decimal, so they're having us say it again, can have the repeating digit be 0. So repeating digit be 0. So when we have a repeating digit that's 0, what that can look like is, say it was like this, and 0 would go on and on and on forever. Okay, this is repeating, but do we write it like this? Nope, we just write it as 2. We would drop down those repeating zeros. We don't need them there. So we can also call them terminating decimals. So terminating, I want to make sure I'm not spelling that funny. Terminating, that's an N. Decimals. Decimal is a repeating. Oh my goodness, me and my pen tool, we're just having a day. I don't know why I did a Q there. Repeating decimal, which has a repeating digit of 0. So it means it terminates, it stops. We drop it off. We don't put all the zeros on there. There's no use for them. So if it is repeating, we need to indicate that it's continuing on and on. But if it's zeros, then we can drop them off, and we call that a terminating decimal. All right, so let's convert fractions into decimals down here. So we have 3 divided by 4, and we can do this, 3 divided by 4. So I'm going to show you this off to the side here just as a refresher for division. So normally we'd say, well, how many times can 4 go into 3? Well, in this case, none, right? It can't go into 3. It's too small. So we would add 0.0, and remember this decimal needs to go straight up here. That's going to be part of our answer, and we're going to have a 0 here. It can't go into 3, but if we pretend like this is 30, 4 can go into 30. So we can, in fact, divide 30 by 4 or figure out how many pieces we have. And at the most, it's going to be 7 times. Remember, we don't want to do decimals yet or, find pieces. What we want to do is find out how close we can get to that number. So the closest we can get is 28, and we would subtract. So 30 minus 28, or if you did, you're borrowing, you'd have 10 and 2. So 10 minus 8 gives me 2. 2 minus 2 gives me 0. So now I have 2 here. 4 can't go into 2. That's too small, so I would add another 0. And remember, that's going to go straight up above here. So 4 can go into 20 evenly. I know it can. And it can go in 5 times. So now when I subtract, sorry, I should put a subtraction sign there, I get 0. So now that's terminating. I have found the end of this answer. So this would be 0.75. I wanted to show you really quick because I know we do use calculators sometimes in class. So I wanted to make sure. When we do this, since it was 3 divided by 4, when we type this into a calculator, we go 3 divided by 4. That's what a fraction means. It's the top number divided by the bottom number. And then just make sure you hit equals, and it will give you this answer as well. So just make sure you're typing that into the calculator correctly, because if you type it in backwards, you won't get the same answer. 3 divided by 4 is not the same thing as 4 divided by 3. They are different problems. So just make sure when you're typing it in, you type in the numerator first, divided by, that's what the fraction line means, the denominator, the bottom number. All right. So now if we go through and we do this one, and I'm going to show you this on a calculator again. So we have, I didn't mean to close it. Now it's going to take a minute to open. So we had negative 2 over 9, or negative 2 divided by 9. So with this one, if I want 2, most calculators will have a symbol like this. Some of the school calculators, if you're just using the kind of regular school calculator, not a phone or a computer, it'll be actually at the bottom, somewhere close to the equal sign usually. But you can hit this little swap button, and it'll give me a negative 2. And then I can go divided by 9 equals. So here is a repeating decimal. Does this mean it stops right here? No. This just is as far as the calculator is willing to show me, and it just ends it. But I can definitely tell this is continuing, okay? So it's only going to show me so many digits. It can't show me all of them because it never ends. So when we write this one, we want to go negative, and it was 222, right? So we don't go negative 0.2222. We go 2, and then we put a line over it because that 2 is what's repeating. So be careful. Only put the little line over the digits that are actually repeating. Sometimes that first digit doesn't repeat, or even the second digit doesn't repeat. You have to make sure you put that line over the digit that's repeating. All right? In this case, it's 2, so I can just go ahead and do that with this one. And if we were to do the long division with this problem, we keep getting the same answer here. So I'm going to go, I'll go ahead and write it out a little bit here. So we'd have 0.0 because I can't divide 2 by 9. So, but I can go into 20, and the closest I can get is 18, and that's 2 times for 9. If I subtract it, I'd end up with another 2. So I'd put another 0 on it. I wouldn't put another decimal though. So then I can go in another 2 times here for 18. So if you notice, it's going to keep doing that. I'm always going to end up with 2, and then I've had a 0, and the closest I can get is 18. Every single time, it's going to keep repeating that same pattern over and over again. So once you notice that this is repeating, you stop and go, okay, I'm just going to put my line over that number that's repeating there. All right, let's go ahead and scooch down here and look at these other pieces. So this one threw off a few students in class. They said, well, how do you put a mixed number in a calculator? You don't necessarily have to put the mixed number in the calculator. On these ones, I had 0 on the front because I'm starting with a fraction. I have no whole number here. But if I'm starting with a whole number, instead of 0, I'm going to have 4 on the front. It's going to be 4 point whatever this fraction turns into for a decimal. And this one is going to be 3 point whatever this fraction turns into as a decimal. Okay? So I'm going to clear that out, and then it would help if I remembered off the top of my head. 13 divided by 25. So we have 13 divided by 20. Whoops. Can I back up on here? Normally on the phone you can actually swipe backwards and it'll back up. I don't know if that'll work. Let's see. I think that's actually correct. I'm going to make sure. 13 divided by 25 equals... Okay, so when I hit clear, it just cleared that one mistake out, and it did work out correctly. I just wanted to make sure the calculator wasn't being funny. So I'm going to go back in here. And so 13 divided by 25 is 0.52. Remember, I have the 4 in the front already. I already know I have whole 4. So I'm just going to put 52 on here. So it's 4.52. I'm going to do the same thing with this one. And again, you can do the long division on this one. You can use a calculator. Kind of depends on your teacher, maybe which method they are asking you to complete it with. So for time's sake, I'm just going through and I'm showing you on a calculator here. So 1 divided by 11, and we get this funny repeating decimal here. So I'm actually going to minimize this so we can see them side by side for a second. Bring this over here. So this was something that I asked in class when we looked at this repeating decimal, is we have 09, 09, 09, 09, and then we get to the end here and it's a 1. Well, what happened? Why is it a 1 now? That looks different. Well, the reason is it rounded. So what they were doing is they were looking at this last piece here, because there would be a 0 and a 9 here, and they said, well, 9 is 5 or bigger. That's my rounding rules. So they rounded the 0 that should be right here up to 1. They just rounded. So keep that in mind. The last digit may be different if the following number is going to be 5 or bigger, okay? Because they're going to use those rounding rules. So we have the repeating decimal of 0, 9. So I'd go 0, 9, and I'd put a line over the top, 0, 9. Make sure it doesn't go over the 3 point. That's not repeating. Only 0, 9 is repeating. All right, so now down here we have, in a recent season, NASCAR driver Jimmy Johnson won 6 of the 36 total races held. To the nearest thousandth, find the part of the races he won. So he won 6 of 36. So this is just reading the word problem. Whenever you hear of, it's going to mean division. So we want to do this division here. And I can reduce this pretty easily. 6 and 36 both divide by 6. 6 divided by 6 is 1. 36 divided by 6 is 6. But we need to know the decimal. So we actually need to do the division. So again, either we're going to do the long division, we're going to come over here to a calculator, we're going to go 1 divided by 6. And here we have this repeating decimal. And again, if I didn't reduce and I just did 6 divided by 36, it would give me the same repeating decimal. So you don't really need to reduce in this case. We're not interested in the 1/6. We're interested in this end repeating decimal. And again, we notice there is a 7 on the end. That's because the 6 is round. So if there should be a 6 here and another 6, well, 6 is 5 or bigger. So it rounded this 6 up to a 7. So we have 0.16, and then they start repeating. I'm not going to put the line over the 1. The 1 does not repeat. Only the 6 repeats. So the line only goes over the 6. So we have to be careful about that when we're completing that step and making sure that we put the line over only what's repeating. And they wanted us to go to the nearest thousandth. So I'm actually going to go to the next page here so that we can kind of review the decimal places. Oh, and I put that right on top of the page here. So if we look at the top of the next notes page here, then we can see, and I know it's a little blurry on my page. It's really clear on the printout. It's just because of the way I took the picture here. It came out a little blurry. It was just a little small, and the more I zoom in, the more blurry it gets. So we have it going all the way from 100 millions down to millionths. So when we're looking at this, we always have a decimal, and that's where we're basing these names off of. So this is where our name comes from. So we have ones column, tens column, hundreds column, thousands column, 10,000s, and we keep going up from there. And each time here we'd have a comma, right? For every 3 digits you get a comma. And it's just a way to separate it. It's actually a way to make it easier to look at and easier to identify, because the more digits we have, if we didn't have any comma separators, it's a little harder for our brain to just jump into that and go, oh, that's millions. Oh, that's 100 millions. But with the comma separators, a lot of the time it's a little easier to tell, especially with smaller numbers. You can see thousands or 10,000s pretty darn easy with that comma separator. All right, so when we go to tenths, hundredths, thousands, so there's no once, we don't have a one section. We go straight to 10. And the way I like to look at this is actually if I put a 1 in the ones column, and then I start putting zeros here. Well, this looks like 10. So tenths. There's just a decimal here, so I know it's not a 10. It's a decimal. Tenths. If I put a 0 here, now this looks like 100. So hundredths. And again, 1,000. This looks like 1,000 if we pretended like that was a comma now. So thousandths. And again, 10,000ths. I know the comma would start to move here to kind of picture this again to separate it nicely. But we have, if we pretended like there's a comma there, that's 10,000, 10,000ths. So we can kind of picture it this way. I don't know if this will help. This is how I like to have students try to picture, just to remember the names here. So this looks like 100,000. So 100,000ths. And then same thing with millions here. So we'd have comma. And, oh, nope, sorry, I did that wrong. We'd have comma and comma, right? If we pretended like there were commas there. So a million. So millions. So when they ask us to write it out to 1,000, they wanted us to go to 2 decimal places. So we just need to be careful about that. When we type that in, if Alex asked us to do 1,000th, and we only did a tenth or 100th, which is what I did here, that would be an oops. So we actually want 2 6s here because this is 10, 100, thousandths. So we go out and we would just show that it's repeating. And it's okay that it's 2 6s because it keeps repeating the 6s over and over again. So it's not really a big deal there. But we just want to make sure we go out to whatever it's asking us to go out to. All right? Because otherwise, yes, that will get marked wrong if we don't round correctly. All right, so now we're going to take a look down here, and I kind of already scooted down. So we're going to write each decimal as a fraction or mixed number in simplest form. So we have negative 0.14. So I want to write this as a fraction. So if it's not repeating, it's a terminating decimal, what we want to look at is if I were to pretend like this was a whole number, I want to take this decimal and how many times do I have to move it? 1, 2 to get to the end. So to get negative 14, I would have to move that twice. And the reason I want to pay attention to that is because in the bottom, that tells me how many zeros I'm going to put there. So I moved it twice, so I'm going to have 100. If I only moved it once, I'd have 10. If I moved it 3 times, I'd have 1,000. So it just tells me how many zeros to put. It's always going to be a 1 on the front. And then I want to make sure I reduce this. They're both even. I can divide by 2 here, right? So negative 14 divided by 2, I get negative 7. 100 divided by 2, I get 50. So here is my fraction, negative 7 over 50. And if you weren't sure if you could reduce this, you might have to do a little bit of testing. But I know 50 does not divide by 7, and 7 is a prime number, so nothing other than 7 and 1 divide into 7. But the closest I can get to 50 is 49, which is 7 times 7. So I can't get to 50, not evenly. All right, when we have a repeating decimal, we have to change it up just a little bit. So we still do this same idea where we go 1, 2. I need to know how many times to move it. So this is going to be 27, but instead of over 100, we're going to use 9s. And there is an equation that kind of shows you how to work this out, but for now we're just going to go ahead and go with the idea that we use 9s. So I moved it 2 times, so I'm going to go 99. Because 2 times, 2 9s. So if it's not repeating, we use 1 and zeros. If it's repeating, we use 9s. I still have to reduce this guy, so I can divide by 3. I can see that right away that I can divide by 3. If you can see that you can divide by a bigger number, that's perfectly fine. But some students, I always say start with 2 if they're even. If they're not even, go to the next number, which is 3. So you just kind of go through each number until you find something that it can divide by. So 27 divided by 3 is 9. 99 divided by 3 is 33. So they're still not even. That shouldn't happen. They shouldn't go from odd to even. But we're going to reduce these one more time because they can actually reduce again. 9 can divide by 3, and 33 can also divide by 3. So I know they couldn't divide by 2, but I'm going to try 3 again. So 9 divided by 3 is 3. 33 divided by 3 is 11. So because I had to reduce twice, what it tells me is I could have divided by 9, and that would have been 1 reduction, instead of dividing by 3 and then divided by 3 again. Does it really matter if you have to do it in pieces? No, you'll still get the same answer. And sometimes we don't always recognize right away the bigger or the greatest common factor in here, which is 9 for these two numbers. But sometimes students don't see that. So that's why I wanted to show you, if you need to do it in pieces, you'll still get this same answer, which is 3 over 11. All right, write each fraction or mixed number as a decimal. So this is just a little more practice like what we were doing on the previous page. So 2 divided by 5. So 2 divided by 5. So if I write this out over here, well, I can't divide 2 by 5. It's too small, so I need to add a decimal here and 0. And this is going to be 0 up top. It can't go into 2, but if I pretend like this is 20, it can go into 20 4 times, and that's even 20. So I would subtract, and I get 0. It terminated. Once I have a remainder of 0, that's termination. It means there is no more decimals. So the answer here would be 0.4. In this one, again, and we practiced this on the previous page, if I have a whole number on the front here, I know part of my answer is going to be that whole number. I can go ahead and just write it down. It's going to be 2 point. I need to know what this decimal is. So I have 1 divided by 8. And again, I know I can't do that. I'm going to have to add a 0 because 1's too small, and it's going to be 0 point. So now I can go into 10 once, and that's the closest I can get to 10 is 8. So if I subtract, I get 2. I can't go into 2, but if I add another 0, I can go into 20. The closest I can get is 16, and that was 2 times. Sorry, and I'm writing right over the 0 here. And then I have 4 left over. If I do my subtraction here, I would have to add another 0. And I can go in evenly to 40. I know that with 8, it can go into 40 evenly. If I subtract, oh, there's my termination. And to get to 40, I needed 5/8. So here is my decimal, 0.125. So if you're doing this long division and you don't see a pattern, like what we did on the previous page where we could see that we were always getting a leftover of 2, adding a 0, we could get to 18, and then it just kept happening over and over again, that's a pattern. We can see the repetition happening. But in this one, there was no repetition. They were different numbers each time. So I would have to keep going until I either found that termination, meaning that there's no more remainder, it's 0, or I found the repeating pattern. So I would just put 125 on the front of here. Because remember, even though this says 0.125, we're looking at 1 divided by 8 here. But we already know there's that whole number 2. They told us that on this problem. All right, so that was section 1. I will see you in section 2.